Imagine if Earth and the entire Milky Way galaxy actually exists inside an enormous black void. A vast cosmic abyss with a tiny fraction of matter as compared to the rest of the universe. A void that spans millions, even billions of light years. Could this be the reason that space appears to be expanding away from us faster than it actually is? And if that's true, what hidden reality lies beyond this black veil? Could our deepest scientific assumptions be built on an illusion we were unaware of until now? If true, it would suggest that our measurements of the universe have been profoundly skewed from the very beginning. The implications of living in a massive void are enormous. For decades, cosmology has operated on the principle that we are located in a typical galaxy, in a typical part of the universe. This is the Copernican principle, and it underpins much of how we interpret observational data. It states that humans are not privileged observers of the universe, that our location in the universe is not special or unique. It suggests that observations from Earth are representative of observations from any typical position in the universe. But if it turns out that Earth is in a rare or structurally unique region, we may have to rethink how we calculate cosmic distances, how we determine the age of the universe, and explain the distribution of matter and energy across the cosmos. It would also mean that our perspective of the universe is skewed, not just figuratively, but literally. All of our measurements, our models, and even our understanding of time and space might be based on an illusion created by the vast cosmic empty void that surrounds us. We may not be seeing the universe as it truly is, but rather as it appears from the depths of an immense, empty galactic abyss. And now this once fringe idea is gaining serious attention. New research suggests that our Milky Way galaxy may indeed be floating inside a massive cosmic void, an unusually empty region of space that spans some 2 billion light-years in diameter. This new study, presented at the Royal Astronomical Society's National Astronomy meeting in July 2024, strengthens a controversial hypothesis with data drawn from the oldest light in the universe, the afterglow of the Big Bang. If this local void theory proves correct, it could provide a long-awaited answer to one of the most persistent and troubling mysteries in modern cosmology, the so-called Hubble tension problem. The Hubble tension problem is the name given to the mismatch between two key ways of measuring how fast the universe is expanding, and there is a growing disagreement between the two methods. The first method relies on observing Cepheid variable stars to calculate how fast galaxies are moving away from us. It predicts an expansion rate of about 67 kilometers per second per megaparsec. The second method analyzes faint fluctuations in the cosmic microwave background radiation, a remnant dating back to 380,000 years after the Big Bang. This gives a noticeably higher value, about 73.2 kilometers per second per megaparsec. While the discrepancy may sound small, it's significant enough to break the standard model of cosmology. If both measurements are accurate, it signals that a crucial piece of the cosmic puzzle is still missing. Physicists have floated many potential explanations, from changes in the behavior of dark energy to even the radical idea that the laws of physics might vary over time. But the possibility that the inconsistency stems not from the cosmos itself, but from our location within it, has become one of the most provocative theories to explain the problem. Indranil Banik, an astronomer at the University of Portsmouth and lead author of the new study, suggests that our galaxy may be near the center of this gigantic void. Because it's less dense than the surrounding universe, this region would experience a faster rate of expansion. This means that when we observe nearby galaxies within our local cluster, the expansion of the cosmos appears faster than it does in the denser, more distant regions of the universe. It's like measuring wind speed from inside a tornado, We're caught in the middle of something that makes everything appear to be moving faster than it really is. Starting in the 1990s, astronomers began noticing that our local universe contained fewer galaxies than expected. Over time, this led to the hypothesis of the KBC void, named after the initials of the researchers who first studied it. But while the concept of a local void gained some ground, many dismissed it as observational error, or assumed that dark matter could be hiding in these less dense zones, making them appear more empty than they really are. To test the theory more rigorously, Banach and his team analyzed 2 decades worth of data on baryon acoustic oscillations. These are sound waves from the early universe that froze in place after the Big Bang. These waves act like a standard ruler in cosmology, allowing researchers to track the expansion of the universe over time. According to their analysis, it's 100 times more likely that we live in a massive void, rather than a region of the universe with average density. That kind of statistical proof is difficult to ignore. The implications and significance of this model is nothing short of extraordinary. If the void hypothesis proves true, then many of our core beliefs about the universe's age, size, and structure could be based on fundamentally flawed assumptions. If we are sitting inside a vast empty cosmic bubble, then many of our calculations that are based on the uniformity of matter are more than likely distorted. This discovery also reintroduces a sense of cosmic specialness that science has long tried to avoid. Ever since Copernicus removed Earth from the center of the universe, the prevailing view in astronomy has been that we occupy no unique position in the universe, that the universe should look roughly the same no matter where you are. But this void theory challenges that very assumption. It suggests our place in the universe might be more unusual than we've led ourselves to believe, not because we are the center of creation, but rather we may be living in an extremely empty part of the universe. It's a strange irony. The more we look outward to understand the cosmos, the more we may be learning about how isolated we truly are. And it's not just an observational issue, it's existential. If we're actually in the middle of a giant black void, it implies that our understanding of the universe has been influenced, even distorted, by the specific region of space we occupy. But if the evidence continues to build, we may have to accept something far more unsettling than a faster expansion rate. We may have to admit that the universe we've been measuring and modeling for decades is in some sense a local illusion, shaped by the silent, vast, empty void that envelops us. In a cosmos that spans billions of light years, the idea that we live in a lonely void isn't just humbling, it's haunting. It may not only change how we see the universe, but how the universe sees us. This